Birds. They're everywhere in the world today, from the equator to the poles, from dry deserts to the high seas. Everywhere you go in the world, you will always find a bird. Even if you'd rather not. There are somewhere around 10 or maybe 11,000 species of bird alive in the world today, and they have a very wide range of both physical forms and lifestyles. Everything from the long-legged flamingos to the waddling penguins, and from flightless ostriches to the peregrine falcon, the world's fastest animal. But despite this huge diversity, the origins and relationship of the birds to the other groups of animals were unclear to the early pioneers, and even to the more recent students of evolutionary science. Charles Darwin himself, famously a student of evolution in birds, and not just of the Galapagos finches, but also of pigeons, had trouble working this out. There were similarities between birds and various other groups of reptiles, including the relatively newly discovered dinosaurs. The first dinosaurs had been discovered just 30 years or so before the publication of On the Origin of Species. But the missing link that would connect the birds to the theropod lineage of the dinosaurs wouldn't be discovered until 2 years after the publication of Origin. That missing link is what this video is about. But first, we should take a brief detour to introduce something very important to paleontologists: Conservat Lagerstätte. I always thought this was German for something like preservation motherload, although Google AI thinks it's something more like conservation fossil site, which is just way too dry and bland for my liking. And Google Translate's offering was even worse. Maybe the 3% of my viewers from Germany can help out with this? In any case, these Lagerstätte are usually small geographic areas, capturing a short window in the fossil record, but with exceptional preservation. In these places we'll find not just the usual bones and shells, but also soft tissues, the remains of things like skin and muscles, and, crucially for this video, feathers. The Burgess Shale in Canada is a well-known example of one of these sites, capturing a snapshot of the Cambrian explosion, when animals were first starting to diversify around 530 million years ago, and experimenting with some very strange body plans. But of more relevance to this story is the Messel pit, located in southwest Germany, near the cities of Darmstadt and Frankfurt. The amazing preservation in the limestone rock formations at Messel has led to some incredible discoveries, including this awesome fossil of Darwinius, one of the earliest known primates, and more recently this incredible fossil shrimp, which still has some of its internal organs preserved. But as cool as that is, by far the most famous find from Messel, and a few other similar places, is a missing link, sharing clear features of both birds and reptiles. That missing link is Archaeopteryx. Archaeopteryx is a really strange creature. It's relatively small, at least compared to us, maybe about the size of a chicken or a raven, but what it lacks in size, it more than makes up for in weirdness. It has the wings of a bird, complete with the kind of asymmetrically shaped feathers that are very important for flight in modern birds, which it also has some of on its tail. Here are some more pictures of Archaeopteryx fossils that have been found with these seemingly flight-adapted feathers very well preserved. And I'm sure you probably won't be able to see from the image quality I was able to find and use in the video, except for maybe this first one I showed of the isolated feather. But up close you can see the individual filaments of the feather preserved. While I've never had the chance to look at them myself in person, I'm told that when you look at them up close, the filaments in the feathers of Archaeopteryx look very similar, if not the same, to the filaments that we see in the feathers of modern birds. As a bit of a fun side note, analysis done on that isolated feather, looking at things called melanosomes that are preserved in the fossil, showed that Archaeopteryx almost definitely had black feathers. Or at least that particular one did. Archaeopteryx also had a furcula, like modern birds. That's the wishbone that some people will snap to try and make a wish, and if you ever cook something like a chicken or a turkey at home, you'll be able to find the wishbone on the front of the chest by the base of the neck, where our collarbones are. Some theropod dinosaurs like Allosaurus and Velociraptor also had fused together collarbones, and that's what a furcular is, it's fused together collarbones. But most dinosaurs didn't have that, and that makes Archaeopteryx much more bird-like in that respect. Besides the wings and the feathers and the wishbone, the other features of Archaeopteryx are much more dinosaur or reptile-like. For example, birds will fuse together lots of the bones in their hands and their feet, as well as in other parts of their skeleton like the pelvis. And the idea is that the extra strength and rigidity that they get from fusing these bones together into larger structures helps them to resist the forces that their bodies experience during flight. But other reptiles don't really do this kind of skeletal fusion, at least not to the same extent that birds do. Archaeopteryx is much more reptile-like in this way. The bones in its hands and feet are all kept more separate from each other, as are the bones in its pelvis, unlike a bird would do. Besides this, Archaeopteryx's tail is also very long, unlike a bird's. Birds obviously do have tails, and use them for doing things like controlling movement during flight, like, say, tropic birds do, or for doing big mating displays like a peacock. But the tail itself is usually quite short, with most of its length coming from the tail feathers, rather than being fully a part of their body with, like, bones and muscles and stuff. On the other hand, reptiles tend to have very long tails. Imagine something like a crocodile, or Diplodocus, or perhaps the Asian grass lizard, which can have tails 3 or 4 times the length of their body, which actually makes them the record holder for longest-tailed lizard, at least relative to their overall size. Maybe if we pick just one more interesting reptile-like feature of Archaeopteryx to talk about, it should be the teeth. Now, reptiles have teeth, all the way from things like snakes through to crocodiles and T-Rex. But birds don't have teeth. Probably the closest a bird has ever got to having teeth would be something like the serrated jawbone of the giant extinct bird Pelagornis. But birds do not have true teeth, nothing comparable to ours. So, if Archaeopteryx does have teeth, surely then it can't be a bird. But that's what makes this find so interesting for us, and so crucial and important for our understanding of the origins of one of the most widespread and recognizable groups alive in the world today. It has features of both. It has the unfused skeleton and long tail and teeth of something like a dinosaur, but also the wings and feathers and the wishbone of a modern bird. And since we're back to wings and feathers, maybe it's time to ask an interesting question. Could Archaeopteryx fly? I'm going to start this section by spoiling the answer. We don't know for sure. And I do seem to find myself saying that quite a lot on this channel, and some of you might find that answer to be annoying or evasive. But it is the truth. We can never really be certain, not about things that happened so long ago. Remember that Archaeopteryx lived during the Jurassic era, around 150 million years ago. And while the Lagerstätte at Messel has preserved some specimens of Archaeopteryx in truly exceptional detail, there are only around a dozen or so specimens known in total. And while the researchers of some extinct groups would kill to have that kind of sample size, it's still not a huge sample compared to some other extinct groups. But I've brought you this far, so let's look at the evidence that we do have and talk about the current best theories on whether or not Archaeopteryx could fly. These theories basically break down into no flying, gliding, and short bursts of active flying. Pretty much no one thinks that Archaeopteryx could have flown long distances anymore, or even that it could have stayed airborne for long periods. Archaeopteryx was not flying hundreds of miles in a single session, like, say, some geese do, for example. The no-flying theory also hasn't had much support for a long time either. The idea behind that one was that it was using its feathers mostly for insulation, and maybe that it could have done some flapping to maybe help it run faster. But it is worth noting that that theory was never particularly popular, even looking all the way back to the 1800s. The gliding theory has been much more popular. Evidence based on the anatomy of Archaeopteryx's skeleton suggests that it may have had what is called an arboreal lifestyle, meaning that it lived mostly in trees. Now, the idea with the gliding theory is that it could have perched or roosted up in tree branches and then used its feathered wings to glide down either to the ground or to other trees. Now, this theory held a really decent chunk of support for a very long time, as Archaeopteryx seemed to lack the large flight muscles and other adaptations of the skeleton around the shoulders and the chest that allow birds to actively flap and generate flight. So, gliding would allow Archaeopteryx to make use of its wings to move through the air, but without it having to do much actual flapping. However, the prevailing theory now is that Archaeopteryx was probably capable of active flapping flight, but probably only in short bursts for doing things like avoiding predators and getting up into trees from the ground. Lots of people thought something like this was likely, but an analysis from 2018 that looked at forelimb morphology provided some really decent statistical support for this. That study included several specimens of Archaeopteryx, along with lots of different types of dinosaur and bird and pterosaur, and they represented lots of different types of locomotion and flying style. Now, those analyses consistently showed Archaeopteryx clustering with the burst flying birds, things like turkeys and pheasants. Now, that study looked at really detailed anatomy of the forelimb bones, which clearly their shape has important implications for their biomechanics, and then that would relate to how the animal moves itself around. So we might consider that this study from 2018 provides our best current theory and evidence for whether or not Archaeopteryx could fly. And that answer is yes, but only in short bursts. It's also worth noting, like I said a minute ago, we can't really be sure of this. Just because Archaeopteryx clusters with those burst flying birds, like pheasants, it doesn't necessarily mean that they flew the same way, it just means that their bones have a similar shape. So, there we have it, a brief introduction to Archaeopteryx, a small animal with a mosaic of reptile and bird anatomy, representing the missing link between the birds and the dinosaurs. It took over a century from the discovery of this animal to conclusively show that modern birds are the relatives of the prehistoric dinosaurs. But Archaeopteryx was a key part in solving that puzzle. And could it fly? Probably. Maybe. To any of you who are still here, thank you so much for taking the time to watch this video. I just want to take a quick moment to mention that I'm using a new recording setup for doing this one. And if any of you have any thoughts on it, any feedback, if you've noticed anything that could do with improvement, please do let me know down in the comments below. Despite having done this for over 6 months now, I still consider myself to be very new to this video making thing, so any feedback really would be appreciated. Again, thank you for your time, and have a nice day.